This is the valuation of options, and we'll present the valuation formula for an option using the Black Scholes model. So the model will be presented for a European call, but as you can recall from previous video, put call parity allows us to price an option in terms of another form of an option. So you can price a put with respect to a call, and you can price a call with respect to a put. And so pricing just the European call option does not mean that that's the only thing we're pricing. We can also obtain the price of a put from it. In addition, an American call that is dividend protected, or if the stock does not pay dividends before the expiration date, if you recall, we discussed that it never pays to exercise that option before its expiration date. It's better to sell it in the exchange. So an American call that is dividend protected or does not pay dividends before the expiration date can also be thought of as a European call. So let's dive into the Black Scholes model. This is the Black Scholes option pricing model. It looks a little complicated, but it really isn't too bad. It's just a combination of certain factors about a stock and its underlying price and its underlying volatility, and we obtain this formula. So the first thing is we assume that it's a continuously compounded rate of return and that it follows a normal distribution. Okay, so there's another model presented in the textbook that I'm not covering. I'm only covering the Black Scholes because this is mostly the most widely used model. So this is the value of a European call under the Black Scholes model, and C is equal to S0 times N of D1. We'll talk about what all these things mean. Minus E over ERT times ND2. Okay, and ND1, now what is D1? You have to first find out what's D1 and D2 using these formulas here. Okay, how is D1 priced? D1 is the natural log, okay, of S0 over E plus this term that relates to the riskless rate and the volatility of the stock, time to expiration, and so on. Okay, so we'll explain each of these terms. First of all, what is S0? S0 stands for the current price of the stock. Okay, what is it selling for at this point of time in the market? Okay, N of whatever is the value of the cumulative normal distribution evaluated at that point. Okay, at that point D1. So if you look at this plot here, the N of this value, so let's say that this value is D, this point is D, okay, the N of D is just the area under the normal distribution curve, okay, the area under this curve. And so basically you'd just be using one of the normal distribution curves to find what's the area under that, and that would be called the ND, okay, the value of the cumulative normal distribution evaluated at D. So we have two of those. We have one of them evaluated at D1, which we'll calculate using this formula, and one of them evaluated using D2, calculated using this formula. What is capital E? Capital E is the exercise price of that option. Okay, this little e is called the exponential function. The exponent value is 2.7183. 2.71 you can think of it as. Okay, that's little e is 2.71. R again is the continuously compounded riskless rate of interest. Okay, the riskless rate. And T is the time to expiration. Okay, but it has to be expressed as a fraction of the year. So if there's 6 months left until expiration, the T would be 0.5 because 6 months over a year is 6 over 12, which is 0.5. So sigma is the standard deviation of the rate of the continuously compounded annual rate of return. So sigma is the standard deviation basically. And if we use all those values, we're going to get values for D1, we're going to get a value for D2. Then we plug it into this formula here, obtain what's the normal distribution values at D1 and D2, and then we go about plugging in the other characteristic information, and we'll get the value of that European call. So what are some interesting factors about the Black Scholes model? The first thing that we see is something interesting. We continuously talk about expected return the entire time in this class, expected return, expected return. But if we look at the formula for the Black Scholes model, expected return does not feature at all in this formula. Expected return does not come in. The only thing that relates to a stock price is S0, which is the current price of the stock. So expected return can actually help us find that current price of the stock if we did not know what it was. But once we know the current price of the stock, expected return has no impact on the value of the call option. Okay, so regardless of if this stock has a higher expected return than the other stock, it does not matter. The only thing that matters is what is that stock currently trading at. Okay, that's the first important thing. Now, the other impact of other variables on the value of the call option, and we can think of it in different ways and how they actually make sense. Okay, the first one is that the higher the ratio of S over E, okay, which is the higher the ratio of the current price of the stock to the exercise price of the call option, okay, the higher will be the value of the call. So think about it as, let's say the exercise price is $50 and there's two current prices. Okay, there's two current prices. One price is 45 and one price is 49. Okay, the 49 over 50 would have a higher ratio than the 45 over 50. And what does that all mean? The $49 you'll only have to gain $1 in the stock price in order to be able to exercise that option. Okay, that option will be exercised when it hits 50. However, for the $45, you'd have to move a lot more. The stock price would have to move $5 before it becomes exercisable. Okay, so having the value of the stock price that's closer to the exercise price is useful because then it brings us closer to exercising it, and that gives us a higher value for the call option. The other one says the longer the value for the time to maturity on the call, the higher is the value of the stock. Okay, the longer time that you have until the option matures, the more time the stock has to change its price. Okay, the more time there exists for that stock price to cross over the threshold of the exercise price to make it exercisable. Let's say the expiration date is tomorrow and you're at $45 versus the expiration date is a month away and you're at $45. In a month, there is still a higher probability of you crossing 50 from 45 than crossing 50 from 45 tomorrow. Okay, so the longer time that you have until maturity, the higher will be the value on the call. Finally, it says the higher the riskless rate of interest, the greater is the value of the call. Okay, and what would that mean? That just means that the lower the present value, if the rate is higher, you'd have to pay a lower present value to exercise the call. Okay, you'd have to pay a lower present value on that amount to exercise the call. And so the higher the riskless rate of interest, the greater is the value of the call. And we can observe these relationships from our plot, okay, from our formula. So we can see that this ratio features in here. Okay, we can see that this ratio is the ratio of the stock price to the exercise price. This is T, the time to maturity. Okay, this is R, that riskless rate. Okay, so as this riskless rate increases, that goes into this function here. We're subtracting away from a bigger number, and that increases the value of the call. As this S0 over E increases, again it goes in here, that we're subtracting a bigger number away. Okay, and so on. And so based on that, we're arriving at these relationships. The first relationship is the higher the ratio of the current stock price to the exercise price, higher is the value of the call. The longer the time to maturity, which means the higher the value of T, the higher is the value of the call. And the third one is the higher is the riskless rate of interest, the greater is the value of the call. In the next video, we'll do an example that actually works out the solving of this Black Scholes model, and continue on.